We are done with Unit 2. This is our first lesson for Unit 3. Yeah, that was cool, right? 3. Okay. We're going to start out with scientific notation. I'm sure you've seen this before in some grade level that was in middle school. Hopefully you've seen it in science class already. So this shouldn't be too new. It's a weird way for me to explain it, but hopefully you understand it. So scientific notation, it's a way for scientists, and then, you know, like everyone else like us in math class, to represent really, really big numbers or really, really small numbers without having to write a ton of zeros and a ton of place values and things like that. So the rules are actually really, really simple but strict. The first number, the actual number of how I write scientific notation, it must be between 1 and 10. Cannot have scientific notation that's greater than 10. And you can't have scientific notation that's less than 1, so a decimal, right? And there won't be any negatives involved in that. Then you have times 10 to some exponent or some power. Okay, so let's really kind of work this out. Now, example 1 is 48,000. That's not really that big of a number, right? Because we can represent that with just putting 3 zeros. And it really would be kind of counterproductive to write this as scientific notation, but let's go ahead and do it anyway. So basically, behind every number, there's an imaginary decimal place. We're trying to move that imaginary decimal place several times until we get to something that's between 1 and 10. Well, the only number with the actual numbers here besides 0 that can get between 1 and 10 is if I make this 4.8. Right? 48 doesn't work because 48 is way bigger than 10. And 0.48 can't work because it's less than 1. So I'm actually going to move this decimal 1, 2, 3, 4 units to the left. Okay? Now, what I do is I make this a 4.8. We always write times 10. Times 10 is always here. Always, 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 always. Okay? Now, the exponent is going to be that number that I moved the decimal. So that's going to be 4 times to the left. 1, 2, 3, 4. That's scientific notation. That's done. Not too bad. I want you to try these two on your own, right? So go ahead and pause me. But we'll make this happen either way. 505,000. Decimal place here. 1, 2, 3, 4, 5 times. Because I have to make this 5.05. And yes, I have to write 5.05 because that is a little bit more specific, and we need to have the specificity. So this is going to be 5.05 times 10 to the 5th power. Okay, I got to make sure I write these significant digits here. This last one, hopefully you got it. 1, 2, 3. So 2.12 times 10 to the 3rd power. Not so bad. Okay, not so bad. Now, those are numbers that are greater than 1. Let's see what happens when we have numbers that are already pretty small. Okay. Now, it's the same process. We just moved the decimal, but we're moving the decimal to the right now because the decimal's already past that number. I'm going to move this 2 places to the right. Now, that's going to be significant for a second. So 5 times 10, right? I moved it 2 to the right. So this is going to be a -2. This is the cardinal rule. This is the rule. When you have a negative exponent, it never, ever means a negative number. Ever, 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 ever. It just means it's a decimal. It just means it's really small. Okay, so we have to understand that rule. This one here, the decimal's here. 1, 2, 3. I can't move it 4 because then it's 42. And 42 is clearly greater than 10. So this is going to be 4.2 times 10. Remember, to the negative, and we did 1, 2, 3, negative 3rd power. Okay, last one here. It's a little bit bigger. This is pretty much where we want to use scientific notation. So already I know this is going to be 2.3 because I have to make it between 1 and 10 times 10. Right, so this is going to be 1, 2, 3, 4, 5, 6. It's to the negative 6th power. Okay. So there's ways that we can get this done either way. Just a quick add-on to this. Let's say that I had 6.4 times 10 to the 4th power. And I want to put that into a regular number. Well, already I know this is going to be a bigger number, so it's going to be 6.4 or 6,400, or at least 6,400. So basically, the 4 represents how many times I have to move the decimal place away. So if I just put 6.4 and a couple zeros here, I'm moving this 4, 1, 2, 3, 4. My number is actually 64,000. Now, we'll have more practice with that in class, but I wanted to show you how I can go from scientific notation to a regular number. Okay? Less than 5 minutes. I'm awesome. We'll do some in class. See you later.